Good afternoon and welcome to Workshop 1.5, the Beyond IoT event brought to you by Nimbus and Munster Technological University. My name is Kevin Fitzgibbon and I will be hosting and moderating the session this afternoon. During the workshop, please do send in your questions via the chat function and we'll take them during the Q&A after the speakers have presented. Just note also that the session is being recorded. This workshop is kindly being sponsored by Arrow. Gary Hill is Arrow's Regional Sales Manager in Ireland, and I would like to hand over to Gary now to introduce the speakers. Gary.
Great, thanks Kevin, and welcome everybody to the fourth workshop here today, and it promises to be a very exciting one that I'm looking forward to very much. Benetel is a company that has been quietly working away and becoming a global leader and a globally respected name. They work in the area of RF technology and private network design. And with the 5G era just beginning, I suppose their story is still in its first few chapters. So we're delighted to have John Doyle, CTO and founder of Benetel, with us here today to tell the story of where the company has come so far. So John, over to you.
Hi Gary, thank you for the introduction. Yep, so I can just share my presentation. So hopefully you can see my presentation. Yep.
Yes, we can indeed, yeah.
Okay, yeah. So just an overview of the talk, just an introduction to Benetel. Then I'll talk a little bit about our background in small cells and femtocell design. And then actually initially on 3G, then moving on to 4G, then the transition to 5G, a number of the topics that have accompanied that, then 5G private networks. And then I'll also mention some research topics that we're working on. Okay. So firstly, just an overview of Benetel. So we're a mobile equipment company based in Dublin, and also with a design center in Gdynia in Poland. So we have a small cell base station focus for private and virtualized RAN networks. So small cell base stations are I guess macro cells cover, let's say, many hundreds of kilometers or hundreds of kilometers outdoors. Small cells are targeted at indoor applications or let's say dense urban areas or densification applications. So we provide wireless design services, which was, I guess, where we started, and we've moved on from there to actually module design, and from there on to actual base station and or radio unit product design. So our markets are the public safety, private LTE, and most recently the telecom infrastructure market. So we work closely with the Facebook telecommunications infrastructure project, and also we work closely with the ORAN Alliance and implement products to the ORAN Alliance standards, which I will be providing some more details on. And in terms of our work, we engage closely with with Intel and Analog Devices in particular, and through their distributor Arrow in our implementations. So just I guess for our background on femtocells, a femtocell is effectively a small base station that is located in the home with the intention of or with the goal to improve coverage within the home environment. It was, I guess, they originally implemented on the 3G and the 3G era, and I guess we contributed the RF design to the world's first femtocell in 2006. Then did multiple other designs for US and European standards at that time. And we also developed the manufacturing test systems, which were used to manufacture millions of these devices. So that was our, I guess, our start into small cell base station design. So then with 4G, we progressed to building small cell base stations on the Intel T3K system on chip processor platform, and working with analog devices, integrated transceivers, and building modules that are used to build a small cell base station. So the processor plus the radio together are enclosed, and together with software from usual software vendors are companies like Radisys and Altran. So the processor, the software plus the radio transceiver implement all of the functions of a small cell base station. So we supplied, we continue to supply those into multiple applications for, I would say predominantly private network applications. So this kind of really, I guess, came to the fore for us on the private network side, came to the fore for us on 4G. The customer base includes mining, oil and gas companies, some electricity generation companies, and then also public safety. The public safety use case, the base station is often incorporates a core network, so that allows actually at an emergency site the deployment of an emergency cell that will allow first responders to communicate within that coverage zone. Then as we go to 5G, there are quite first of all, I guess in the mobile communications world, there are quite a lot of standards organizations. I guess 3GPP is the dominant one, but then we've had the emergence of the O-RAN Alliance. Then we also have ETSI, Small Cells Forum. As I mentioned, the Telecom Infra Project, which is from Facebook, and many others. So on that transition to 5G, we were working closely with Facebook on various telecom infra projects, and also that progressed on to O-RAN. So the drivers that are, I guess, some of the trends that these organizations pushed was actually, moving from a conventional base station architecture, which is coming from a single vendor. It has all of the, let's say, signal processing and the RF are coming from the same vendor and interconnected via a proprietary interface. So there's an interest in opening those interfaces, which is a disaggregation topic, and then furthermore in moving the software from actually dedicated processing units to actually run on a commercial off-the-shelf server platform. And that enables actually, let's say, cloud RAN deployments and software-defined networking. So these were key, let's say, trends at the beginning of 5G, and are actually key platform concepts for the implementation of 5G networks. So then on the base station side, we did have a proprietary interface, and now we need to move to an open interface between the radio unit and the signal processing side. So there's in relation to that, there are a number of options we can have actually, which have been, let's say, initially investigated by 3GPP and then further developed by the Small Cell Forum, O-RAN, and TIP also. So the CIPRI Alliance. So the connection between the radio unit and the, let's say, digital unit or the processing unit can be at let's say an IQ, a time domain IQ sample level, or it can be at let's say a higher signal processing level, or like an intermediate level, which would be like effectively frequency domain samples. So we've been working on our initial projects. Actually with both Intel and with the TIP organization, we've been working on the what's referred to as option 7, which became the primary interface adopted by the ORAN Alliance, with some, let's say, some minor modifications, which they call option 7.2x. So that has become the basis for the interface between the radio units and the rest of the base station for us in our developments. And we've effectively followed the ORAN implementation because, well, for some various reasons. One is that our partners, we were aligning with our partners there. And then also the logical split makes sense to us in terms of actually managing effectively the trade-off between the latency requirements on the front haul side and the actual data rate and bandwidth needed. Okay, so then when we come to realizing the radio unit part, there are again similar to what we had in the on the 4G side. There's let's say a processing side and a radio transceiver side. So we work with analog devices, integrated radio transceivers as the platform for the radio transceiver implementation, and then on the from the signal processing side, which is less signal processing now in an RU than we would have had previously, and obviously in the full base station. But we work with FPGA and ARM implementations there, and we're utilizing the Intel SoC FPGA devices. So on the FPGA side, we implement the effectively, let's say, converting time domain samples into frequency domain samples and applying compression and some other signal processing functions associated with the wide bandwidth of 5G signals. And then on the ARM device, we host what's referred to as the management plane interface. So because of the goal of ORAN is to enable multi-vendor networks, as well as actually having multi-vendor compatibility on the front haul like data path. We also need multi-vendor compatibility on the management and control of the radio units within the network. So that is achieved by utilizing netconf and yang in terms of in terms of implementing the ORAN open front haul management plane interface, and we host that functionality on the ARM processor. So that implements functions such as, when you start up an RU to establish connection with the DU, functions like configuration management, software management, if there's adding a new software release to the platform, and recording performance counters, performance management, and passing that information to network management systems and network optimization systems. Okay. So then for our RUs, we're focusing on actually both indoor applications. I guess our indoor has been our area of specialization for quite some time. And so we have a family of both 4G and 5G indoor RUs. And we also have outdoor small cell RUs up to 5 watts per carrier per transmit port. So the indoor devices are typically a quarter watt per carrier per antenna port, and up to 5 watts. So then bringing the RUs together into actually into a 5G system, we have two cases. We have the initial 5G deployments where certain functionality, signaling functionality is provided through the 4G network, and then effectively a high-speed data path is provided through 5G. That's referred to as non-standalone. So we have 5G in green working together with the 4G network. So first deployments are mostly non-standalone, and then later deployments are targeting standalone. Now, for private networks, standalone is obviously more, I guess, in public networks, the non-standalone is attractive because there's a transition from 4G to 5G, facilitated for the network operators. But on 5G standalone, it means that actually in a smaller scale private network deployment, there's a need for just a single frequency as opposed to two in this non-standalone case. So then some examples of networks configurations that we have built. We've done some work bringing actually an open source software stack on 4G and 5G together with ORAN, and integrating our RUs to provide a platform, a 5G network, a deployable 5G network for targeted at, let's say, research applications, and for mobile network operators, R&D teams. So it's actually fully open source software stacks above the RU. And then, the open source organization we're working with, OAI, who are, I guess, a spin out from a research organization in France. They have a 5G SA mode in development, which is scheduled for release this quarter. Then for more commercial deployments, we're working with multiple CU and DU vendors. An example is on the software stack side is Radisys, and there we're on the layer 2 and layer 3 integrated with an Intel FlexRAN, which is an Intel upper layer 1 that supports the ORAN interface to our RUs. And these are predominantly standalone 5G standalone integrations, and they are both for mobile network operator deployments, conventional mobile network operator deployments, and for private network applications. So then private networks. So for private networks, we're seeing there's the trend that started in 4G is gaining quite a lot of momentum in 5G. Where, let's say, if we take industrial applications, there's the 5G private network offers the let's say in industry the opportunity to have high performance, let's say, wide bandwidth communication, but also ultra low latency and high density communication within their network, within their building, and with, let's say, with security and privacy, where data, let's say, highly confidential user data can be retained within the limits of the industry premises or terrain, and the benefits. We've seen some use cases where, for example, there are vehicle control of automatic control of vehicles, and use cases that certain other approaches such as Wi-Fi based ones have been tried, but there were concerns about, let's say, latency. So there's let's say, an improved performance on the 5G side. Then doing this network implementation on a private basis provides independence to the industry, and also control of costs. So there are two main Two main ways in which these can be deployed. One can be a fully independent network deployment where an industry owner can deploy a network on their premises, entirely independent of a mobile network operator, or it could be done in conjunction with the public network, or deployed by, for example, the mobile network operator. So some of the enablers for private networks: there's spectrum being set aside for private network applications. There are industry interest groups driving this. For example, in the automotive, the 5G Automotive Association, then also the 5G Alliance for Connected Industries and Automation. For standardization, the 3GPP organization has introduced, I guess they refer to private networks as non-public networks. So they have in release 16, they've presently released 3GPP standards. They've included support upfront for non-public networks, and support for key industrial features such as time-sensitive communications and what's referred to as 5G LAN type service. So then other enablers include software-defined networking features, multi-access edge computing that allows processing of the user's data within the premises, while actually connecting to with certain control signals to external networks. So then on the spectrum side for private networks, there are a number of possibilities. The spectrum could be fully licensed, as in a conventional mobile network operator use case. There are an emerging range of, let's say, lightly licensed or local licensed. So this is licensing at a low cost on by location basis. And then there's an emerging unlicensed. We had some unlicensed applications called multi-fire in 4G, but this is being further extended in 5G. So, with fully licensed, the mobile network operator could deliver a private network using their spectrum. With the lightly licensed case, we can have an emerging new independent private network operator, which could be, for example, the industry owner deploying the network, or they could utilize have the service provided by a mobile network operator, and similarly for the fully unlicensed spectrum. So there's some new frequency bands being assigned for unlicensed in 5G, and they have some benefits beyond what I guess in 4G with multi-fire was utilizing spectrum that was used by Wi-Fi in the 5 gigahertz band, but there's a block in the 6 gigahertz band where there's a potential for, let's say, more effective sharing of the spectrum between users. So then, regarding the lightly licensed one, for example, the UK has made 400 megahertz of spectrum available on a regional basis. There's a 100 megahertz in Germany, for example, and many other countries are setting aside spectrum for this, let's say, locally licensed. Low transmit power is constrained. But it's appropriate for deployments in a local industry area. So then actually to be able to deal with the multiple different use cases, 5G has a feature called network slicing. So for example, certain applications that require very high speed data can be given an enhanced mobile broadband service. Other features that have very high density of devices, of sensor devices, maybe given a massive IoT slice. And then for ultra reliable low latency communications, there's again a feature associated with that use case in 5G. So like there are applications that require perhaps gigabits per second of data, and then there are applications that require, for example, milliseconds or low milliseconds of latency. So then, just a little bit more detail on that. The industry applications could be, there are many use cases, factories, there's a medical use case. There's warehousing, location-based services, and enhanced location-based services in 5G. Then also, for example, control of the automotive use case, then guided vehicle use cases, unmanned aerial vehicle use cases, and then the combined with the edge computing and the slicing, the network can be configured to provide the optimum level of performance to each of the users use cases. On the multi-access edge compute, the processing of the, let's say, critical user data can be retained within the user-controlled environment, and that processing can be brought close to the end user to minimize actually, for example, latency on latency critical applications. And then certain, let's say, certain control information that is non, let's say, end user, let's say, sensitive, and that is necessary, for example, for users, let's say, roaming through a network that can be processed externally from the user's premises. Then just a final slide on some of the activities within Benetel. There are, again, many RF technical challenges that implementing these networks present, and we work closely with a Connect Research Centre here in Ireland, and a number of the topics that we're working on are, with 5G, we will see many more paths communication in the radio units, and there's a feature to optimize radio performance called digital pre-distortion. So we're working on an optimized version of that to deal with multiple linearizing multiple transmission paths with let's say some common or shared signal processing functions. Then we're also the performance, the power consumption of the radio units is a critical factor, especially as we get into actually in all cases, really, in the indoor and in the higher powered outdoor use cases. So we have ongoing research work on pushing the efficiency of the power amplifiers to higher levels, and that has a number of, for us, there are a number of attractive aspects here in that it helps us, let's say, understand what performances can be achieved with certain technical approaches, build IP in those areas, and also build engineering expertise for new, let's say, new team members of our company. But we have some designs here which are showing, I would say, like very, state of the art, or very close to in terms of actual efficiency performance. We're also involved with EU research programs involving many other partners, and there we're involved in again front-end RF design for millimeter wave applications. So most of our, let's say, current product range is in the sub-6 or sub-6.5 gigahertz or so, but the we're building expertise and IP on the millimeter wave side as well, and see opportunities where we can extend some of our sub-6 gigahertz work to millimeter wave. So then, just in summary, we've started, with small cell work back on 3G femtocells, progressed all the way through to 5G. So, from 5 megahertz bandwidth systems up to now 100 megahertz and greater. We've seen the emergence of 5G networks, or emergence of private networks, and together with opening of interfaces, virtualization, cloudification, spectrum licensing, and densification needs arriving concurrently with 5G. We're actually positioning ourselves to be able to address to address these demands with our 5G implementations. And 5G, it's a generation that is of, in let's say 3G was internet on the phone, 4G was mobile broadband, 5G is effectively vertical, supporting vertical markets, and that includes IoT on a massive scale. So we're working closely with our partners, Arrow, Intel, Analog, and our software partners to play a significant role in this emerging and rapidly growing ecosystem. So that concludes my talk. Thank you.
Very good, and thank you very much for that, John. Now I'd like to open up to questions, and we do have some questions that have come in from the floor. So what I'll do is I will pass them to John, if you like, and
Yep.
you can maybe address them. There's one here: for commercial stacks, will Benetel be the one point of contact to bring the solution together, especially RRU and ORAN?
I guess I would say with commercial stacks, we're working with different DU vendors. So effectively, that's that question. I anticipate refers to the DU and CU implementation. So let's say, for example, DU vendor could license a stack from Radisys, and then we would integrate with that DU. So it's as an RU vendor, we would not be licensing a stack from a commercial stack from an organization such as Radisys or Altran, but we would be integrating with that commercial stack in our lab, and then also integrating with DU vendors who have licensed such stacks.
Okay, a technical one: are there TX power limitations on a private user network?
There are actually, yes, yeah. So I don't remember the exact figures offhand, but I think it's maybe something approximately like 27 dBm or so for a local area in the UK. I think Ofcom have published their requirements, and then if that's in a, let's say, an urban or area. And then in a very, let's say, sparsely populated rural area, that power can be increased to, my understanding is approximately 5 watts. And other countries will be implementing similar power limitations. I guess the licensing is there's also an area-based element to the license, so that is in line with the power.
Yeah. Another technical: what are the maximum nodes could connect to Benetel RU?
The maximum, okay. So if we're talking about the user equipment, UEs, okay, so that is actually limited by, let's say, the processing in the. It depends on the by, let's say, the type of UE, but in principle it's limited by the processing in the DU and in the CU parts, the distributed unit and centralized unit in the base station, we'll say. So rather than actually the RU part itself. And there are actually, that's kind of introduced to, there are a number of topics associated with this. So for example, there are, some DU implementations that can be implemented purely in let's say in software on a server, or they can also have accompanying the software offload of certain processing intensive activities to, for example, to FPGA or to other processor types, and they can be used to actually increase the number of UEs that can be connected to a particular DU. Then also there's another ORAN feature called shared cell, which if in, let's say, in an in-building environment, maybe where density of users is or the number of users per cell is lower, then actually multiple RUs can be either cascaded or combined to implement a single cell in a building, and that actually reduces the processing needs on the DU side, and again allows more users to be connected.
Okay, couple of questions in then from one contributor. Can these solutions be used in an ATEX environment?
I'm sorry, I'm not familiar with
an
the
ATEX
term.
environment, explosive risk of explosion, that kind of thing.
Okay. Yes, that's a good question, and I would say we have had this question posed to us, but I would say that I need to, it's not something I could answer, that I can answer immediately right now, unfortunately.
Yeah. Okay.
So, yeah.
Okay. Could these systems be deployed running from batteries for short or medium-term use? And the example is a warfare environment.
Yes, like, let's say the where we're looking at in the 4G use case, there's a goal for, let's say, for particular applications, for example, the tactical applications, that size, weight, and power consumption are considered to be very critical items, and this is actually required for the let's say operation for, let's say, operation from battery case, and also for portability cases, and aware, in on the 4G side, I would say that actually or let's say where you have an SoC plus radio transceiver, in those use cases, it is actually feasible to have battery operated applications. Where we've looked at a disaggregated RAN implementation, where you have an RU connecting to a server, I would say at that particular configuration is very flexible for, let's say, for software-defined networking applications, slicing applications, but effectively, the server power consumption is a relatively, although it's a shared element across multiple nodes, it's still a high power consuming item. So
the high overhead.
Yeah, I'd say there are kind of three possible, from a base station point of view, three possible implementation platforms. I would say so like let's say at the lowest level, or the highest integration level, we'll say we have a system on chip where, let's say, higher layer software plus signal processing software is implemented on a dedicated device, and there, for, let's say, a single carrier LTE, that could be around sub 10 watts, 7 watts or so. Then when you go the next level up is, say, FPGA implementation, and there that power consumption is moves up to, let's say, 20 or so watts, depending on the functionality, I would say, but around the 20 or so. Then once you introduce servers or x86 type servers, the power consumption increases in a further step. So I'd say in order for the lowest powered implementations for, let's say, tactical applications, that would really be a system on chip based implementation, of which there are some emerging right now, or an eASIC, like a version, an ASIC implementation of the FPGA based system. So those are steps that can be done to bring the power consumption down for tactical use cases. So.
Okay. Final one maybe. In terms of your private 5G networks, you mentioned for industry that these are not possible. What scale of operation is necessary for an industry typically to justify the investment that would be required and the maintenance of that overhead? Because it strikes me that this might be something that you would need to be of a certain size and a certain number of connected pieces of infrastructure in order to justify the investment.
Yes, that's true, and that is actually like a valid point. But I would say that we've seen like the use cases, I would say, are emerging. So and with we have built a 5G network from an open source implementation, which has an extremely, let's say, low cost configuration, and then we see everything that runs from there up to actually let's say very, say organizations that are like very large, let's say automotive manufacturer or automotive parts manufacturer type organizations, which are very large. So I think there's a scaling, a scaling need there. But I think that the factors that will really drive this are the 5G performance, where the let's say ultra low latency is required, and the reliability and the ability for other features such as the very high speed data. So it's I think the networks will need to to scale to support the scale to support the size of the organizations that need to be that have the service need. So.
Okay, well, I think that brings me to the end of the questions that we've received anyway, John. Gary, I'd like to bring you back in if you'd like to either comment or have any further questions.
No, I think that's a fascinating insight, and thank you, John, for your openness and sharing your knowledge and experience and your vision on the route forward. We have a very knowledgeable audience here. I recognize some of the names, so I think it's been very good of you to share the experiences of Benetel. So I guess that's the end of our sessions here today. So the only thing remains is to thank you, Kevin, in Nimbus, and all the rest of the Nimbus team. You facilitated us here very well. Thanks to John and all the other presenters, and thanks very much to the audience for being very informed and asking great questions. So already looking forward to next year, and hopefully, Kevin, next year we'll get back to a real time and actual event as opposed to the virtual event.
We would like to think so, with fingers crossed. I suspect it'll be a hybrid event. We'll probably we'll retain the best of both worlds, hopefully, Well, thank you for that, Gary, and thank you, John. I would like to echo Gary's comments. What a detailed and depth of knowledge, detailed presentation and depth of knowledge you've portrayed for us today. My own knowledge of 5G has gone up by about 2 orders of magnitude, so I much appreciate it. I'd like to thank John, thank Gary for his sponsorship, and Arrow for their sponsorship. I'd like to thank our attendees at this workshop, indeed all of our speakers and attendees throughout the day. I hope you've had a very informative day and that you've managed to get the most out of the various stages and workshops and platforms. If you have found that you couldn't take advantage of everything that was on offer, there will be recordings of the sessions that will become available, and we will share the details of this on our social media platforms that you will have already seen active promoting the original event. So on that, what I'd like to do is just conclude the session and say thank you very much again, and have a good evening.
Thank you.